Good morning, everyone, or maybe good afternoon for some of you. Here in Portugal is good morning still. We are going to start our weather briefing for today. This is me. I'm Angela. I'm working in the Portuguese Met Service. And I think we are going to start at this moment. So I would like to ask you, where are you coming from? It's nice to see where are you listening, from where you are listening to this weather briefing. Okay, most of you from Central Europe. Well, I would like to show you first, before we start with the weather briefing, I want to show you some dust events that we had over Europe in the last days of March, and I want to show you this dust RGB, where you can see this pinkish color over North Africa, and that represents the dust. So you can see over here the dust storm that was over Northern Africa, and then the dust was transported through north, and of course when it rained, this system over here moved towards east, and there was some mud rain over Europe. So it was an interesting event last days of March. Also, we had here yesterday in Portugal, we had our share of some mud rain. But less severe than this one over Europe. So this dust RGB, it's of course for detecting some dust, but also there are other applications. So we can use it to distinct moisture boundaries and SO2 plumes. So you can use also this RGB for another applications. So, from 6 UTC today, so we have here over East Atlantic, in this area here, we have deep low with dense frontal clouds. They are moving northeast, and some interesting jet cloudiness over here in this area, and which means that we can have some severe turbulence over this area. And we have also a warm front band over this region here. Also over the Atlantic, we have here from more or less northern UK, a sharp and deep trough towards south of Açores, and a low system over here with convection. Yesterday was a little bit severe yesterday, this convection. Of course, we can see clearly this reddish color here, which means we have here some stratospheric air, so dry descending stratospheric air. You can see later with water vapor image a dark area over this region. Also some bluish color over this area here. which means that is a cold air mass with a low tropopause. So here also we have a weak frontal system that is moving, so it's more or less this area here, and it's moving east, causing high pressure that is more or less in this area. High pressure over the Western Europe is going to weaken over this area, because this system and also this one, they are moving eastward. And across Central and Eastern Europe, there is a trough over east, extending into the Balkans and Greece, and we had, I'm going to show you later, we have here some thunderstorms over this area. And of course also over Iberia we have another low in this area with convective cloudiness, very whitish here, so high clouds, thick high clouds over this area. Yesterday we had over here, and during evening hours we have some thunderstorms over here. So we have some low-level warm air that is advected, and of course we have more thunderstorms expecting in Iberia, mainly diurnally driven thunderstorms, of course with the solar heat help. So the water vapor image here with 300 hectopascal is very important to check the upper air dynamics. Some of the features, the main features that we can see in the water vapor image are the moisture and dry boundaries, position of jet stream, areas of dry descending stratospheric air that I mentioned before, where there is high potential vorticity, and of course water vapor images are also important to check model performance, and you can use in the ePort webpage, for example, the simulated water vapor image from ECMWF to compare with the real one. So it's a very good tool to use for model performance. So here we have the jet I was talking about. We have also another jet over here. The black region with the dry descending air, and of course we have some also another region with dry descending air, so stratospheric intrusion, and we can see very well the convective cloudiness over this low system south of Azores, and of course over here some convective cloudiness. And here is some frontal cloudiness associated with this frontal, long, wavy frontal system that we have, that comes from these latitudes towards north. And this is the image, water vapor image with potential vorticity, the height where PV equals 1 PV unit, and you can see the areas I was talking about, the stratospheric region with high values of potential vorticity, and of course this area is here well seen, less here, but some, and of course also here, and in this area here with this deep low over Northeast Atlantic. Finally, from wind at 300 hectopascal, we can see more or less the jet. So I was talking about this one here, and goes further south, and then we have this one here, and some branches over Northern Europe, and Central and Eastern Europe. So let's see what we have from the perspective, warnings perspective. So more or less quiet day for Europe. Some mainly some windy and thunderstorm warning, thunderstorm warning over here, some coastal warnings over here, and wind over here also. So, but anyway, it's a calm day for Europe. So this is the area over Greece that we have some convective cloudiness that are associated with a cold front that is going up north. Here we cannot see very well. Maybe this one here. So you can see it over there, the frontal system. So we have here some convective cloudiness, and we'll see some heavy rain also. This is from nowcasting SAF, so convective rain rate, our hourly accumulation. So we can see very well heavy rain over here, and some also convective rain. So this is an image from the day microphysics. This is very useful for convection. This area here is this area over Greece, and you can see that we have some orange color over here, so is where is more active and severe updrafts. So we have orange color, that means small ice particles. So strong updrafts in this area. The use of 3.9 it's very useful because we can see the cloud size and phase also. So this orange means that we have here small ice particles, so strong updrafts. If there is more reddish color, it's a convective cell that is already decaying, so it's large ice particles, so very useful for convection. So moving for another subject, we have here some information from ASCAT data over the Atlantic. This is Azores Island. I wanted to show you this very well region of discontinuity in the wind field in this area, not only in direction but also intensity, so wind speed is very different. So ASCAT information over the Atlantic is very useful for this kind of thing, so we can detect low and high pressure systems and discontinuities in the wind fields. So this is this area over here, so where there is the frontal system, it's somehow weak, but we can see the discontinuity in the wind field. This image is from midnight, but we still have this morning this frontal system over the Atlantic. Another example, very interesting, for the same hour at midnight, and you can see very well this discontinuity in the wind field. So we have here more or less where is the frontal system. at surface, and here it's very interesting to see this southwesterly winds and northeasterly or easterly wind here. So we have high pressure system over this region. So I want to show you some a closer look at the low system over Iberia. This is from yesterday at 12. This is we have here several areas with some degree of instability. So over Iberia, it was very active yesterday, and we are expecting today that more or less over this region to have more thunderstorms today. So this is this area was really with high values of instability. Another way to see the instability is using the isotopes and use the vertical cross section with the isotopes. In this case, we are seeing this this vertical cross section here, and this helps to evaluate the static stability over this area, and we can see that the vertical spacing between isentropic stability, for example, this is very stable air, and this is this area here in very unstable air. Another useful information using isotopes is when the values are increasing with high. In this case here, we have a stable area, stable air, and when values are increasing with high, decreasing with high, sorry, in this area here we have 314 Kelvin, and here is 312 Kelvin. So you have a very unstable air. So here is, of course, almost over this area here. So we have some very unstable air over this region yesterday. So information, another RGB that is very useful for convection, it's the severe convection RGB. I'm going to show you some this area here, mainly this system over here. So the severe storm RGB uses the brightness temperature differences on red and green, and the reflectance difference on the blue beam. And severe convective clouds appear yellow with small ice particles. So because we have the first difference, so the first brightness difference, this one here, it's almost zero, with high levels of humidity in the mid and high levels of the troposphere. We have this one here is large, strong updrafts, so we have high green in this difference. We have the small ice particles, and this one here, it's a large negative value, so we have large absorption of 1.6 ice particles. So ice particles, there is a low albedo of ice in this wavelength. So the result is yellow in the small ice particles. So if we had large ice particles, this color may not be very could, but thick ice clouds, we are talking about large ice particles, and thin ice clouds, large ice particles also. So, my last example from ASCAT, this was midnight, and I was talking about the useful of ASCAT data to detect low pressure system. So around midnight, because this pass was around 9:30, 10 p.m. yesterday, but we can see very clear the center at surface. So it's very useful to this data from ASCAT over the Atlantic. So I'm ending this presentation. Some maybe Easter 20 April we may have some westerly weather over the Atlantic, but it's far away still, so we are waiting for the Easter forecast. And finally, the next weather briefing will be on 22nd of May, 9 UTC, from with Zanita from EUMeTrain. Thank you so much.